Oh, we're live. What's up, guys? My name is Michael, and welcome to my YouTube channel. Today, I have not actually done any competitive programming at all. So today, we're going to do a virtual contest of 675. Sorry, guys, if I haven't been uploading at all. It's been pretty hectic for the past 2 weeks, and I couldn't upload any videos at all. But so yeah, I'm gonna do a live stream today just because I also I have not been practicing competitive programming at all. So yeah, this is a good way to get back into the zone. You know what I mean? So yeah, pretty good. Yeah, I have been dealing with a lot of schoolwork and stuff like that. Yeah. So let's just do this Codeforces round 675. I have not seen any of these problems yet. I haven't even done any of these problems yet. So yeah, and we're gonna do it. Let me know if there's any thoughts on New Boston reappearance. New Boston is reappearing? I did not know that. Really? He's coming back? Oh my gosh. This is crazy. This is actually crazy. The New Boston is coming back. Huh. That's crazy. I thought you just got a job or something and you just left. But yeah, him coming back is pretty cool. I used to watch him when I was a kid. For like learning basic programming, but not like I didn't watch him when I was like a kid. I used to watch some of his videos on like Photoshop or something. He used to have videos on that, I think. I don't know. Of course, I never actually did any of this stuff here with him. But yeah, wow. I didn't expect him to come back. But yeah, it's good. It's good if he's coming back. All right, let's get started. Let's do this. I have not been practicing at all. So this is going to be a very hectic for me. Have not been practicing at all. But it is something like that, you know. I got to get rid of this. I got to get rid of these. Got to get rid of this. Oh, I got to get rid of this. Okay, so we got rid of those. And yeah. Okay, so let's do this. 1 minute 02 seconds. I feel like technically, I feel like I could get to green. Actually, if I just like practice, like get a little more faster, I'm pretty sure I could get to green. Because green is not actually that far away from my skill level, I think. Like I'm green on used to be green on top coder. So I did that. I think that I did one of the contests there, and then I was green, and then I got to high gray again. But I'm pretty sure my level is like, I think I could get back to green on Codeforces. Like, I don't know. What are your guys' ratings? But yeah, don't know. I feel like ad coder is probably the hardest in terms of difficulty. That's just me though. Maybe I'm just not as good as math. But ad coder is way more difficult in my opinion. All right, let's get started. Fence. You want to build a fence? You got 3 straight fence segments of ABC. You want to find some possible length D of the 4th fence segment so that you could build a fence using these 4 segments. In other words, the fence should have a quadrilateral shape with side lengths equal to A, B, C, and D. Find any possible side of the 4th side. What? 1, 2, 3, 4. It just has to be a quadrilateral? Fence would have a quadrilateral shape with side lengths equal to A, B, C, and D. Fence should have a quadrilateral shape with side lengths equal to A, B, and C, and D. Can you take the average? I don't know. Let's see. What is 12 plus 34 plus 56 over 3? $34. Oh, that's 42. Let's see. How do you get 42? 56 minus 12 would get you 44. No. What do they mean by fourth straight fence segment? Quadrilateral shape with side lengths equal to A, B, C, and D. So any like a trapezoid? Can't you take any number? Hold up. Pretty sure side lengths are always properties of rhombus. Let's see. Bisect each other perpendicular. Opposite sides are equal. Opposite sides are parallel. No, that's not what I want. Okay, you know what? I'm going to read in the test cases first. And then we could think about that soon, okay? So while t minus minus, let's read in A, B, C. Okay, so now we have A, B, C. So they said all side lengths are equal. Is that what they say? Is a quadrilateral that no three of its corners lie on the same line. Should have a quadrilateral shape with side lengths equal to A, B, C, and D. Okay, so let's say we have 34. 1, 2, and 3, and 4 works. 7 plus 2 plus 5. 5 over 4. No. 5 plus 1 is 6. 5 divided by plus 3 is 6 plus 1 over 4. No, that's not right. 12 plus 34 is 46 plus 42 is 84. If there are multiple answers, print any one that exists. Okay, so I think you could just print any of them such that the number is greater than... So they can't lie on the same line, right? And that only happens if 3 of them are the same side lengths, right? No, that's not right. If the fourth one is equal to the sum of the first 3, then you can't do it, right? Like 3 plus 3 is 6. If the fourth one's 6, then it's not possible. Wait, no, that's a triangle. Hold up. If the fourth one... Yeah. Wait. If it's equal to 6... 3 plus 3. I need to draw is there a way to draw like a... Draw a coordinate. Draw a quadrilateral, yeah. Is there a way to do it? Is there a program I could do? So let's say the first one is 2. The second one is 3. They said 3, right? I can't do that. Let's say any. Second one is 3. Third side length is 4. Just like that. 2. So it's 1, 2. So 2, 3. It's 2, 3, 1, 2, and 3. 1, 2. Let's do 3 here. And that's about 4. Okay, let's just test. Let's just test it, okay? So like I don't know, A plus B plus C. I'm not sure if this works. So we have 5, 101. I don't think that's right. Let's see. Six divided by 3 is 2. 2 plus 34. How do you get 42? 12 plus 34. Let's see, 12 plus 34 is 46. Let's say divided by 2 is 23. 23 plus, no. 36, 56 minus 36 is 20. No, that's not right. How do you get 42? That's a big question. 56 minus 34 is 22. No, that's 32. 22 plus 12 is 22 plus 12 is 34. That's not right. I don't know. $42 plus. Okay, let's see what is the average of 12 plus 34 plus 56. 144 divided by 3. One 44 divided by 4 is 36. 6 to 4, 10. 4 is 2 point something. All right, actually, let's just see if this works. I don't even know. Not even sure if this works, actually. Wait, did I get accepted? Wait, what? That was it? Okay. Yeah, I didn't expect that, but some of them all to -1. Yeah, I don't know. That was that was just by luck, not gonna lie. Okay, now we have matrix that n by m is nice. If all rows and columns of the matrix are palindromes. Okay, that's okay. Rows and columns are palindromes. Okay. Sequence of A1 to AK is a palindrome if it equals the AK minus 1. Okay, yeah, I know that. Now Sasha owns n by m. One operation you can increase or decrease by 1. You want to make the matrix a nice, so then you want to make it a palindrome. Okay, what is the minimum number of operations she needs? Okay, so you could go over row by column. Okay, so first you. Okay, so we have 4 rows, 2 columns. 1, 2, 3, 4. So this is our original 4 rows and 2 columns. 1, 2, 3, 4. Okay, so you can make this into a palindrome by changing it into 2, 4, 4. 2, 4, 4, 2, 4, 4, 2. So if you make the row and column is a palindrome. Okay, so we could make 42 operations. Let's see, what could you do? You could subtract the beginning from the end, and then that'll get you your... Okay, so we're going to loop through each of them, right? Here, we're going to take the first number and subtract it with the end, right? And then we're also going to take the last number from the column section and subtract it with the first value of the beginning one. And we're going to add them up. And then we're just going to keep doing that. And then each time we're going to update that when we go down a row. So, okay, so if I do like, how about I get my thing to draw it out? Okay, so if we do like, let's see. Let's say we do 4, 2, what was it? 4, 2, 4, 2, 4, 2, 2, 4, and then 4, 2. Okay, so what if we go row by row? So from this row, we're going to compare to this to the mat last. Subtract it until we get to the middle, right? Once we get to the middle, we're done. And then while we're getting to the middle this way, we're also going to subtract each row downwards. So we're going to subtract this by this. Oh, wait, 4, 2, 4, 4, 4, 2, 4, 2. Oh, whoops, my bad. I drew it wrong. So 4, 2, 4, 2, 2, 4, 4, 2, 2, 4. So we're going to loop through this way. So we're going to loop through this way, and then we're going to subtract this from the end. While we're looping through this way, so each time we're going to go through each of the individual columns from here to end, we're also going to subtract each individual with its end. So that'll get rid of that. And yeah, we're just going to keep doing that until we get to the end. So like if we had like, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to start from this row, subtract here to this end, right? So then 3 minus 2 would be 2. So then I'm going to change this into like a 3, right? Then I'm going to compare this with its last column here, last row here. So that's 3, 4, 7. Ooh, okay. So it takes 4 moves to get it to 3 to become 7. But it takes more moves if I want to change both of these, right? I have to take another 4 moves. So it's actually better if I make 7 back to 3. So I'll make this 3. So at this point, we have 2 moves to get 1 to 3. And then we have 4 moves to get 7 down to 3. Right? And then after that, I'm going to get to here. So remember, I'm looping through from each individual row to the right. So now I'm here, and then you need to check this. This is a done with the end. So I'm going to take this one and with its last one and change 2 to 6. So then 8 is going to become to 2. And then I think I am done with that. So it becomes 6. The problem is that wouldn't it be better if I'm trying to think. What if we make all rows to become the same number? Yeah, hold up, like this. Okay, so we have one. So let's say we have this. 1, 2, 3, 4. Okay, so we have 1, 2, 3. Second test case, for example. 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Okay. So here they made all of them to become 5. 5 and 6. Why did they do that? Maybe it's the average, actually. 7 plus 2, 10. Divided by 2. Divided by 4 is 2.5. No, that's all right. Median? Let's see. What is a median? No, median 6 and 7. What is the average of 2 plus 3? 1 plus 2 plus 3 plus 4 plus 5, 6, 7. Oh, okay. What was the average of this? 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 plus 4. 5 plus 6 plus 7. Plus 8 plus, was it 9, 10, 11, 18. $84, and now we're going to divide it by how many rows? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. 18 divided by 12. Oh, wait, no. Wait, it was not 18. 84 divided by 12. That's 7. Average is 7. Why would it be better to do it to 5 and 6? Okay, let's see. Make it the total? Total sum. 2, 4, no, that's not right. Maybe it is the average. I'm trying to think. 6. 13 divided by 2 is 6. Ah. It's the middle numbers average. What about this row? 12 divided by 4 is 3. No. 7 plus 2 is 10. No. 3 plus 3 is 6 plus 4 is 10. No, that's not right. 6 plus 9 is 14 divided by 3. I don't know. 9 plus... 9 plus 2... I'm doing a bunch of math. Nice thought process. Well, actually, it would be surprising if it's just printing 1. Don't fall for the average. Test case is set up like that. Don't fall for average. The test case is like that. Huh. Don't fall for average. So don't use average. Should I just like make it into a palindrome then? Like, I was thinking of just like subtracting, going through and just making it into a palindrome. But like, I don't even know if that's right or not. Okay. Let's try it. Okay. Because originally I was just going to go through every single row and just make it into a palindrome. You know what I mean? Because you technically could just do that. Go through every row, make it into a palindrome, then go through every column. Like, you can make this, so like, back to 1, 2, 3, 4, 5, 6. I make this into a palindrome, make this into a palindrome. Yeah. So I get like 6. And then here. Wait, hold up. Yeah. Then the rest of the rows, you could just make it into... Wait, hold up. Yeah, you have to go through... So... Okay, so if you have like... Hold up. This is difficult. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's go back. 1, 2, 3, 7, 8, 9, 10, 11, 12. Okay, let's say it was like this, right? I make this into a palindrome by comparing this and this. So I compare this and make this into a 3. Okay? And I need to make this into a palindrome. So I compare this with this last row. So make this into a 3 also. So currently I have like 7 plus 2. The number of operations I did. Yeah. Then I'm going to go to here. I'll make this into a palindrome. Comparing here. And this last row. So make this into a 2. So I need to make this to a 9. Make this into a palindrome. Compare 3. Make this into 3. So then now we have 9 again. Okay. But then I need to, after I'm done with this row, I have to go to the second row. So I can't just go through row and column like that. So yeah. Okay. So I went through here. So the first row, then now I'm in the second row. Let's make this into a palindrome, compare this to this. So make this into a 4 or 2. It actually doesn't matter. Make it 6. So now we have plus 2. Then I need to compare this minus this. So this and this instead. So now this is going to become 6. Yeah, 6. So it's actually better if you make it the larger number. Or is it better to make it smaller? Actually, the larger number is better. Yeah. Yeah. 6, 6. And then this one, let's make this into a palindrome. So make this into like a 5. And then at this point, once you're here, you make this into a palindrome. So make this back to a 6. So then you would have like 1, 3, 2, 3, 5, 6, 5, 6, 6, 5, 6, 3, 2, 3. Okay, so yeah, I'm going to do this algorithm. Okay, so yeah, let's do that actually. I don't know if it's the smallest number of operations required, but might as well try. So let's read in N and M. Okay, so we read in these two. Read in these two, and let's look at M. Yeah, okay, so we need to create like yeah, okay, so data, let's do like, yeah, data, n rows, and then for every okay, so now we're just gonna do data at I is gonna equal to new vector m, and then now we're gonna read in data at ij. Okay, so now we have our data. Now let's try to find the minimum number of operations. Okay, so okay, I'm gonna do R actually is for row and column. So we start at the number of rows. I want to go until I get to the middle actually. So I don't want to go all the way. So I'm gonna do like n over 2. For every row, for every column, I want to go halfway also. So this is gonna be m over 2. And I want to make sure for every column I'm going to subtract C minus data at RC minus length minus 1, I think. N minus, hold on. So this is 0, this is 0, 1, 1, 2, 0, 1, 2, right? So I'm going to take the last row and subtract by the index minus 1. Yeah. Okay, so it'll be last row minus index minus 1. Number of rows, so we have 3 minus the current index, 0 minus 1, so that'd be 2. Okay, so last row. So that's going to be m minus c minus 1, right? So I'm going to take data at row in this column. So I'm going to take this column, and I'm going to subtract this from at the current column. Yeah. Okay. So that would get me the this is going to be the number of operations. Yeah. And then I'm going to make whichever one to be the larger one. So if it's the larger one, I'll make the smaller one to become the larger one. So I need to check which one's larger. So yeah, 4 relates to 3, 2, 1, 2. Okay, yeah. So if data at RC is greater than data at the n minus 1, then I set data at R of MC minus 1 is going to equal to data at RC. Otherwise, I set data at RC is going to equal to data at RM minus C minus 1. Yeah. Okay, so I'm going to do that for all the columns. But then for every row, I have to do that the same thing, right? Because while I'm going through the columns, I need to do the rows also, right? So I have to do like n minus r minus rc, I think. So while this is doing the whole thingamajiggy, so I'll compare the first and the last, and then its original column and row with its last row. Okay, so yeah. Okay, so after this, I also need to compare. So remember back over here, if I want to do like 1, 2, 3, I'm going to compare this with this, right? And make this into a 3. I also want to compare this with its corresponding n to make this a 3. So that way when I go through to the middle, it'll be able to do it. And then after it does that, it'll go to the next column and I'll make it do n minus. Yeah, okay. So yeah, I think that would work. That'll work. That would work. I think it would work actually. Yeah. Okay. So while it's doing that, I also have to compare. So I'm going to do like another operation. So here I'm going to do, now whether it's going to be a minimum operation, I don't know actually. So this is going to be second operation. It's going to be RC data at row and column. The last row, so it's going to be data at n minus r minus 1, same column, right, minus this. Right? Yeah. Okay. And then what we're going to do is we are going to do the same thing as here. Okay. Except it's not this anymore. It's going to be if RC is greater than n minus r minus 1. Yeah. Then we do C. RC is greater than n minus 1 minus 1. Then we're going to set R of this is going to equal to whatever is greater. Yeah. So whichever is greater, then we're going to set that to equal. So otherwise, this one is going to equal to the last row minus 1. So it'll equal to this. Yeah. So this is just setting whichever is greater, right? So if this is greater, it's going to set the other one into it. Otherwise, we set itself into it. Yeah. Okay. So it's going to do that. And then now what we're going to do is we're going to add the number of operations together. So let's do like a total op equals 0. And then we're going to add. So we're going to do sec ops plus ops. Okay. Total op. Total. Oh, I just misspelled it. Total op. Okay. Total. Yeah. Okay. So now once we have that, at the end it should be fine. Ideally, unless I miss a boundary. But then yeah. And then let's just see out total op. I'm not 100% sure this works, but I don't know. Okay, so I got 6 and 16, so that's not right. I think a little bit off. Let's see. Let's actually print out the array at the end to make sure that we're not actually going crazy. So at the end, let's print out the whole array. Okay, so once we print out the whole array, let's see. All right, what's the problem here? 9, 10, 3, 4. Wait, why is this? What am I doing wrong? So I set the first one to be 9. Something's not right. Okay, hold up. I need to print another new line. Let's see. Okay. 9, 10, 3, 4. So I did this to make it 9, then I made this 10. So 3, 4 doesn't get changed, and it doesn't get changed for the rest of these either. Okay, so the problem is that it did not finish changing the rest of them. Let's debug this. Okay. 9, 10, 3, 4. So let's do one test case of this initially. Okay. Okay. Let's do one test case. 3, 4. And then let's do this. Let's do this. Okay, let's see what's going on. Okay, so we got initially. Okay, so this is gonna operations subtracted. Let's see, what did it subtract? Okay, so R minus N, M minus C minus 1. Yeah, that should be right. So that'll get you RC equals data of R minus M minus 1. So M row is number of rows. Oh, wait. No. Okay, wait. What did this do? Let's see, what did it do? It made the first one into a 4. Yeah, okay, so it made this and this to be a 4. Okay, so then now it should make the nine. Yeah, let's see. Then it made the first one to a 9. Okay, that's not right. Okay, so if the first one is a 4, if both of these are 4, you have to make the last one to a 4 also. So you can't just take the largest one. Yeah, you have to take you just have to make the. Okay, yeah, so we cannot do the larger one here. We would have to just make n minus r minus 1. Yeah, we would just have to add that. So we would just have to do this. Because if you make it the largest one, you have more problems. Yeah, you just have to do this. You would just have to subtract with its original one. Yeah, okay. So that's for the row part, why it's not right. Hold up. So let's try it again. 3, 4. And then let's look at the test cases again. Okay, so let's see. What did it change? So 4, 2, 3, 4. And last row should be 4. Yeah. Okay, so that's right. Okay, so then it should continue. So what did it print out? Well, what's the final array? 4, 3, 3. 5. What is it? 5, 6, 7, 8. Okay, that's not right. That means we have to continue doing it. 4, 3, 11, 18. That's still not right. Okay, so that means that we have to actually continue doing it until we get to the middle, which means we have to make this into an equal sign. So let's try it again. So let's do 1, 3, 4, and let's do this. 4, 3, 3, 4, 4, 3, 3, 18. Why is the last one not working? What if we don't make it equal? What if we just, instead of going halfway, we just go all the way? Ah, crap, I messed that up. Okay, so we got it. I think that's right. Okay, yeah, I think that's right. You might be able to do a proof of this. Greedy stays ahead. 842, is that right? Yeah, 842, that's right. Okay, so yeah, we got this answer. Yeah, just make it a palindrome while you go through it. How long did it take me to do this? Wrong answer on 2. What is the problem? 842 works. In what situation would this not work? What if it's already a palindrome? Let's see what happens. Zero. Okay, no. I don't know, actually. I'm kind of stumped. What is the problem? Just keep going back here. What are we assuming? We are assuming that when we go through the whole array and that we just set the larger value here, that the larger value is always going to be the one that has the most operations. What if you want to set the smaller value? In fact, what if you want to set the bottommost value? Maybe you should make it to the median. I don't know. What do you guys think? Test cases set up like that. It's not an actual median. Don't fall for average. Should you use median then? What if I... Hold up. Let's go back to here. What if I do this? Would I get the same number? No, I would get out of bounds. Nah. What if the last row is equal to the previous one? What if that's a problem? I'm trying to think of many different test cases that could happen. Let's see. 4, 4, 4, 4, 4, 4, 4. Nine, 6. What if it's 6? I'm trying to think. 3, 4, 5, 6. 1, 2, 3, 4. What if we make them all ones? Would that work? I don't even know. 1 plus 2. Okay, so we have 1. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 17. No, that's not right. You get 72. Seven, 1, 9, 1. 7 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. I don't think that's right either. This gives you 17. It's all right. How do I know if it's the minimum? That's a big question. median. Make it to 5. Let's see. 4, 3, 2, 1. Wait, hold on. What is a median? 6. It's a median 6 actually. 5 plus 4 plus 3 plus 2 plus 1. Let's see. 5 plus 4 plus 3 plus 2 plus 1. What else? Plus 1 plus 2 plus 3 plus 4 plus 5. $18 minus 6 is 12 plus 12. Oh! Just make them odds to the median. Oh, what the? I think that'll work. I think that'll work. How do you get the median, though? You have to make it into an array and just get the middle number. Okay. Let's try to get the median. Med about pushback. Okay, so now I have med. Okay, so I'm gonna do a completely different thing. I'm just gonna make everything into the median. All right. So So now we push everything into one giant array. Now what we're gonna do is we're gonna get the middle number. That's well, what is that? Med at med dot size over 2. Right? I think that's right. Oh no, but no. If it's odd, hold up. If it's odd, then we have to do plus 2 over. Let's see. This was 1, 2, 3, 4, 5, 6. This is 12, right? So 1, 2, 3, 4, 5. So we had to do 6 plus 7 over 2. So if it's even, we have to take. Okay, so if it's even. If it's even, we're going to do median is going to equal to med dot size over 2 floor. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 1, 2, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3 times 4 is 12. 12 divided by 2 is 6. So it'll be 0, 1, 2, 3, 4, 5, 6. So it's going to be 6 plus 6 minus 1, 0, 1, 2, 3, 4, 5 over 2, right? So med dot size. Then we're going to do a minus 1. Yeah, and then we divide it by 2. So this is going to get us a median. So here we're going to do, otherwise it'll just be med dot size over 2 divided by 2, I think. So it'll be like, it'll be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So originally, if it was like ended here, it'll be 0, 1. So it'll be 1, 0, 0, 0, 0. So if this didn't exist, it will be 1, 2, 3, 4. It'll be, hold up, 1. Wait, hold up, 1, 2, 3, 4, 5. So it'll be here. So 0, 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. So it'll just be 10 over 2. Okay. Yeah, so it'll be 5. Okay, so then, yeah. So let's actually use a ternary operator. So if me.size mod 2 is equal to 0, then we're going to equal to this gigantic number. Otherwise, we're going to make it equal to me.size over 2. So this. Yeah. Okay. So that just gives us a median. Once we have the median, let's just go through all the values and subtract it from the median. So let's go through all values. And then we'll take this minus median. Right? And then we're going to do total ops. And then we're going to do like an ABS. Yeah, then total op. I think this would work, but I'm not 100% sure. But it seems right. So let's see if this works. Did it work? 842. Okay, so that worked. Let's see if this works when I submit it. It's taking a while. Did my internet die? Was Codeforces down? Should at least get through the first one. I don't know. I think maybe Codeforces is down. Maybe my internet's down. Is my internet down? Yeah, I was thinking about the median. That was the second part. No, I haven't read the chat at all, so I wouldn't know. I wouldn't know if that's right or not. I think Codeforces is down. Why is this taking so long? Is this pushback? I mean, I didn't even... I'm pretty sure this is how you calculate median, though. Right, if it's mod by 2 is equal to 0, so that means even. So if it's even, we take the smaller number here, we add it with the other middle number, and we divide it by 2. Right? Is that how you do it? Otherwise, you just take the middle number. But I don't know. I don't know why it's taking so long. It's taking awfully a long time. Let's see something. Is my algorithm too slow? Whoops. I'm trying to think. I mean, we could just get rid of the data at IJ. I don't know. We still need that. Maybe my internet's just slow. I don't know. Let me just close everything. It's really weird that the fact that it's taking awfully a long time. Oh no, I got wrong answer. Oh no, it's still, Verdict is running. Give me something. Why is it taking so long? Maybe I should try resubmitting it. I mean, I don't know why it's taking so long. Already submitted it once. Okay, in that case, let's just make median equal the size over 2. Maybe it's just a weird... I have no idea why it's taking so long. Now both of them are running, not stopping. I don't know. Maybe something's wrong with their thing. Maybe we go to C. Okay, let's go to C. Sometimes it's easy to come to an argument with a bargain. You can't come with an agreement. Sasha makes the price as high as possible. She wants to move as many digits from the price as possible. If more details, she names some integer price n, removes a non-empty substring from the place. The remaining digits close the gap, and the resulting integer is the price. If you have 1, 2, 1, 3, 1, 2, 1, you can remove 1, 3, 2, 1, and the result is 1, 2, 1. You can remove all digits and the price will be 0. She wants to come up with the constraint so that you can't remove all the digits, but she wants some arguments supporting the constraint. To do start with, she wants to compute the sum of all the resulting after remove. What? Okay, wrong answer on 2. Okay, so now it works. So both of these are wrong answer on 2. Okay, so median does not work. Subtract them all to make the median. For some reason that both of those did not work. What if we try average? Let's try average. If median doesn't work and average doesn't, median doesn't work, so let's try average. Okay, we're gonna do maybe it was because of a floating point error actually. Wait, hold up. Let's see, what was the problem? Could be this floating point. Round it up or round down? 6.7 divided by 2 is 13 divided by 2 is 6. Round down. So this would work if it was median. Let's try average then. Okay, we're gonna try average. Make all the numbers the average. Okay, so we're gonna do average plus equal data at ij. Now we're gonna do average divided is equal to average divided by data n times m. Yeah. Okay. Then we subtract average. So let's see if this works. Good. We still get the same number. I still feel like median makes more sense, but still wrong answer on 2. Mode. Make it to the mode. What if you make it to the mode? What is the mode though? If it's all the same, then you have to use the average. Or the mode is 2. Or what if the mode is 4? Okay. let's make it to the mode, okay? So the one with the most number of occurrences. Let's do that. If that doesn't, if the maximum mode is 1, then we use the average. How about that? So let's actually get all the occurrences of each number. To do that, yeah, let's use a map. So let's do map occur. And then now we're going to do at data at I at j, and we add up. Yeah, so now we have the occurrences, and now we need the maximum occurrences. So that's, you need to loop through the max occurrences. So let's loop through the map. Okay, so if, why can't I do this? Oh, occur. If x dot second is greater than max occur, I don't know, number, whatever this number is, let's make max occur equal to negative infinity or something. Long under. So if it's greater than this, then we said max occur is going to equal to the number, which is the first pair. Yeah, so that'll be the mode. And then, yeah, we'll just continue. Once you get the mode, so once we get the mode, if the mode is equal to, crap, okay, so if the mode is equal to each other, if the mode of, okay, if all the values in the mode is equal to 1, then we're going to use average. So we actually need to, okay, so we have to go through the map again. If all the values of the mode, so if second is not equal to 1, so let's say it's not equal to 1, then we break, we say use average. Don't use average. Don't average. So don't average equals the true. No, it's not 1. You don't want all the values to be the same. Max occurrences. That's what you don't want. You don't want to make it equal to 1. Okay, so if the mode, because, okay, you don't want all the occurrences equal to, okay, so the mode, if we use the mode, okay, so like, if we go back to here and we use the mode, right? There is no mode here because they're all equal to 1. But let's say there's 2 of each, then there's still no mode, right? Because they're all equal to each other. So we have to check if all the occurrences don't equal to the previous occurrences. So we're gonna have to have like a variable previous occur. Let's say it's -1. Not -1. Underscore infinity min. Okay, negative infinity. No. Dang, this is so difficult. This got harder and harder. Okay. Check if, okay, hold up. Check if if second pair in map is the same in C++. Second, oh boy, that's really difficult. Check if second, that's not what I want. It's got complicated and very complicated. Too complicated, actually. Very complicated. Oh, check if all values in map are the same. Oh, you have to do this. That was stupid. Okay, well, I don't have to loop through it again. I should do this. String. So let's create a set. New. We don't need new. We just create a new set. This set is going to equal to dot values. So it's going to be occur dot awk. Get all values in a map. Oh, push every value. Check if they're. Okay, we could do this. Push every value into a. Let's create a set of key values. Then we're gonna insert it dot second, and that's it. So values dot insert. What is my value? Awk. Oh. Okay, and then now we do if values dot size is equal to 1. That means there's no mode, right? No mode, so that means we're going to use the average. So we'll do this. Okay. Otherwise, we're going to actually use the mode. So then we're going to use the mode. So we'll use... Now we're going to use the mode. So we're going to take max occur. So we're going to copy this and paste here. And then we're going to add subtract by mode. Yeah. Where is it? Okay. And yeah, that'll be pretty much it. Okay, let's see if this works. What's the problem? Oh. Total ops redefinition. Oh. Yeah, it's the same thing. Okay, let's try this. Damn, mode doesn't work. Dang. So how do you use this then? If mode is not working, okay, so if mode doesn't work, average doesn't work, then what is it? If the mode doesn't work, how many number of occurrences? Mode doesn't work, average doesn't work. How do you do this? We tried mode, we tried average, we tried median. Retried every single possible central tendency. What was it called? Central tendencies. How do you get this equality to hold? I tried it. Nothing's working. Okay, let's go back to our original definition. This. Making it into a palindrome. What is the minimum number of ways to make it into a palindrome? That's basically what this problem boils down to. Minimum ways to make it into a palindrome. Oh, I got it. Okay. Okay. Go back to our original thing. Okay, we have two choices. Let's get back. Okay. I think I got it. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have two choices. This one, I can make this the same as this and this, right? I either can make this the same as this, or I can make, okay. If I want to make this, we need the minimum number of operations that take to make this, right? So in the beginning, this 1, I could either make this 1 into a 3, or I can make this 1 into a 7, right? So if I make this 1 into a 3, I have to make this 7 into a 3. So the operations this would take would be 3 minus 1 plus 7 minus 3. So this is going to give you 2 plus 4, which would equal to 6, right? So that's one case. The other case I could do, so remember we have 3 minus 1 plus 7 minus 3, right? That gives us 6. The other cases to do is to make this into a 7, right? So if we're going to make this into a 7, this is going to be 6. 7 minus 1 gives us 6, plus we have to make this into a 7 also. And that's 7 minus 3, which is going to give us 4. 7 minus 3, which would give us 4. So this would give us 6 plus 4, which would give us 10. Okay? Or we could make, so we can make 1 into 3 or 7. We can make 7 equal to 1 and 3 equal to 1. We could also do that. So we have 3 cases, right? So we have, let's do this. 3 minus 1 plus 7 minus 3. So if we go back, I want to make this. Right, so this is one of our cases. No. Yeah, whatever. So, or I could do, I could make all these into 1. So I could make this 7 into a 1, and I could make this 3 into 1. Right? So remember we had 3 minus 1 plus 7 minus 3, right? Or we could have make them both into 3s, so then no, not 3s. Make them both into 7, so 7 minus 1 plus 7 minus 3, which gives us 10. Or we can make each of these into 1s, so that would be 7 minus 1 plus 3 minus 1, which gives us 6 plus 2, which gives us 8. Okay? So it's actually better if you make it into the largest number, right? So Actually, is it the largest number? 7 minus 1 plus 3 minus 1. So 7 minus 1 plus 3 minus 1. So this make the smallest. This one make it to the middle number. This one make it into 7 minus 1. 7 minus 1. This one is, this will make it into 3, right? 7 minus 1 plus 7 minus 3. 7 minus 1. No, this is making it to 7s. Wait, hold up. So 3 minus, okay. Back it up. My brain just got even more confused. My brain is so confused now. Okay, so let's go back to. Okay, so we have a few cases. Let's make this into a 3. Right? So let's make it the middle number. Then we do 3 minus 1 plus 7 minus 3, which gives us 6. Okay? Or we can make it the largest number. So make it to 7. So this becomes 7. This becomes 7. So now we have 7 minus 1 plus 7 minus 3, which gives us 6 plus 4, which gives us 10. Or we could make this into the smallest number. So make 3 into 1, 7 into 1. So then we get 7 minus 1 plus 3 minus 1, which gives us. Okay. So it's actually better to make it into the middle number, the median. Okay, so let's actually do that instead. I think the median subtract, make it into the middle number is actually the best. So originally all we did was we just made it into whatever is rightmost. And I think that's what somehow worked. That's not always the case. So it's actually better if we get the middle number. So when I say median, I mean like the median of this, this, and this, right? So 1, 3, and 7. Okay. So yeah, let's do that. Okay, so we could just take yeah, okay, so if we're gonna do it the median of the middle number of all 3 of the cases. Yeah, okay, so we need like the first case is the end. This is the initial row. We need to find which one is larger. So we need to do like so if data C is greater than data at R and data at R M minus C minus 1 is greater than data at R data at N minus R minus 1C. So what would be the middle number? So in this case, let's actually rewrite this because this is a little confusing. And this is greater than data. So data at this is less than. Okay, so data RC is greater than RM minus C minus 1, and data at N minus R minus C is less than this. So median, it would be equal to too many conditionals. All right, I'm gonna do a stupid thing, but it might actually be a best case to do this. Let's just push all three values and then sort it. There's just too many conditionals. Too many conditionals. Okay. Okay, I got this. I'm gonna sort. Okay, then we'll just take the middle one. So there's only three numbers, so 3, 0, 1, 2. So it'll just be 0, 1. So it'll be the first number. Meet at 1. So meet at 1 is gonna be the middle number. So okay, so now what we're gonna do is we are going to just subtract each values from the mean and add them up. Yeah, and then we're gonna convert them all equal to the mean. So every one of these just becomes the mean. So we're also gonna do total op. Total op is gonna be plus equal to data at R minus mean. Why can't I do this? Mean is middle. Yeah, so we're gonna repeat this 3 times. This is gonna be, I'm too lazy to write this. I repeated this. That's not what I wanted to do. No, I lost something. What was the math thing? It was this, N minus R minus 1. N minus R minus 1. See, yeah. Okay, so we add all those, and then we just make all of them become the middle. Okay, so this huge equal sign just makes this to equal to the right. So this makes equal middle, this equal to the middle, this equal to middle. Yeah. Okay. Add them up. Yeah, I think this would work. Not 100% sure though, but I think it would work. Eight and 46. Dang it. 1, 4. Okay, what does it give me? Let's see the code. Four three three four 8778 4334. So it's not just the middle, whichever is the middle number. 149 to what if we just subtract every case and see if which one's the smallest? Because we don't know if the middle number would give you the smallest every time. Right? Yeah. So let's just... How do you know which one would give you the smallest? Sort 137. Did I sort it? I did sort it, right? 7 minus 3, 7 minus 1, 7 minus 2. I just don't understand. I don't understand. All right, they say don't find the median of the whole matrix. A of n minus r of c minus 1. We need to think of the perfect destination for these four numbers. I mean, that's what I was trying to do. I don't know. One, two. So we have this, this, this. Then we have this, this, and this. This, this, and this. So we got to place the first four numbers. We still got 30 minutes left. Let's think. The more we think, the better. Oh my gosh. Oh my gosh. Typo. Oh. Maybe this will work now. That was the... Work. It works! Yes! It worked, guys, it worked. Sorting it, finding the middle number of this, this, and this actually puts it at the best area. So like 1, 3, and 7. Find the middle number, that'll always get subtracting it would work. Okay? So like 1, 7, 3, 8. So yeah, that worked. Wow. My problem was this typo. Yeah, but it worked. So yeah, that worked. That's crazy. Yes, that worked. Oh, that was crazy. All right, let's go to let's go to the next one. Bargain. Bargain. Okay. Okay. Bargain. We still got more time. 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 Okay, let's go back to here. Okay. Let's see if we could finish this C. Very difficult. These problems are difficult. It took me 5 tries. 4 tries? 5 tries. Yeah, 5 tries. And that's an hour and 30 minutes also. Jesus. Louise. Up, I did better than this guy, though. Nah, no. Well, he solved in 19 minutes, but I don't know. Yeah. That was difficult. Difficult. Okay, let's do this. Okay, it is not easy to come to an agreement in a bargain, so she can't come to an agreement. Sasha names a price as high as possible, but then Novetta wants to remove as many digits from the price as possible. In more details, she names some digits n and removes a non-empty substring from the price. Okay, the remaining digits close the gap, and the resulting digit is the price. So if you name 1213121, if you remove 1321 this, you remove that, the result is 121. It's allowed for the result to contain leading zeros. If you remove all digits, the price is 0. Sasha wants to come up with a constraint so that Vova can't just remove all digits, but she needs some arguments to support the constraints. To start with, she wants to compile the sum of all possible resulting prices after Vova's move. So we've got 107. Why is it 40? So you could choose to remove 0, 1, 7, 1 to 0, 2. Resultings are 0, 7, 1, 7, 1, 0, 7, 1, 0. Their sum is 42. $17, 24. 0, 0, 7, 0, 17, 1, 1, 7, 7. Remove. So we remove the 1, we get 0, 7. Remove 0, we get 1, 7. Remove 7, we get 1, 0. We remove, what else could we remove? 1, 0, you get 7. Remove 0, 7, you get 1. Remove 0, 7, you get 1. What about 0? We remove all of them, you get 0. So the number of ways you can remove 1, 2, 3, 4, 5, 6. So it's 3 times 2. So it's n factorial, right? Oh, Lord. I think you need to use dynamic programming, actually. You might need to use dynamic programming. Oh boy. Okay. Remove 1, resulting is 0, 7. Remove 0, resulting is 17. Remove 7, 10. Let's see. Let's think. How many different stages can you have? Let's say I've looped through 0, 1, 2, 3. 3 stages, right? If I remove the first one, this is the optimal solution, then the answer would be 0, 7. I remove the second one, 17 would be the optimal solution. With the third one, 10 would be the optimal solution. But if I remove 0, 10. 7 would be the optimal solution. So if you... Oh, wait. Divide and conquer? Yeah, I think it might be divide and conquer, actually. Okay, hold up. So we have 1, 0, 1, 0, 7. I remove... So if I choose 1... So what if I split this into halves? 1 and 0, 7. So I have to add 1 plus 0, 7, regardless.
I can learn to understand you much better if I can get familiar with the way you talk.
What was that? That was weird. That was super weird. Okay. But then what if I split it over here? Right? But then what if I split over here? Oh, but that's 107. No, you can't do that. Is his answer 42? 7, 8, 25? No. 7? Oh, because you can remove the middle. Rats. So we have 107. Remove this. Rats. Plus 17. Is this 42 now? 8 plus 25. It is 42. Okay, so, but the problem is, what if I have like 1, 0, 1, 7? Huh? So now that here's a problem that now if you split this, then you have 1 plus 0, 7, right? Then you split this, so let here 1 plus 0, 7. Now let's say I have 1, 0, 1, 7, right? And we split here, then we add 10, 17. Then what if I have 1, 0, 1, 7? We split here, and now we have 101, 7. But then now you have to think about, what if I have 101, 7, and I want to remove both of these? Then I have to add 17 again. Right? And then what if I want to remove this one? Like, what if I have 11117, remove this one only? 107 again. Can we remove as many digits? Yeah, hello. Hello. Let's see. Because then if you remove as many as you can, you could have... This is going to get you 18 plus 10 plus 17 plus 101 plus 7 plus 17 plus 107. That'll get you... What would that get you? What is that going to get you? Let's bring out a trusty calculator. Okay, we pull this out and let's do whoops. One plus 17 plus 10 plus 17 plus 101 plus 7 plus 17 plus 107. 277. That's not right. Is that right? Hold up. Let's try their largest solution here. This 1015. I don't know what this is. Let's see if this works. I can't even draw on this for some reason. I can't even draw on this. 1015. Why can't I draw on this? Whatever. Okay, well, at least I tried. 105. 100 500 100 500. Let's try splitting. Okay, so we split this here. Then we have 1 plus 500 Then let's split over here. So now we have 10 plus this same thing. No, wait, actually it is the same thing. Let's split over here. 100 plus exact same thing. Let's split over here. So this is different now. Wait, how many did they get? Okay, this is really weird. 1005 plus 00100 let's come here. 10050. Wait, 10050. Yeah, plus 100500105. Okay, so now let's take this whole thing. Okay, let's cut this part. 1005000 plus 1005000. Let's cut this part. 1005001 plus 5001005. Let's split here. 1005010 plus 05004. Is this greater than the other one? Okay, I'm gonna pull out my trusty calculator because I don't trust this. Let's see. Okay, so I already got over 25 million. Is that 1, 2, 428? Let's see. 1, 2, 1, 2. Okay, wait, I got way more than that. 1, 2, 400. Yeah, I got way too much. That's not right. But I think splitting might actually be the thing that is the way to solve this problem. What if we don't re-add the same number? So let's say we had this. Then we take this and we don't add this again, so we just plus 10. We split this, don't add this again, so we just plus 100. We split this, now we do have to add the rest, so now we do 1,0,0,5,0,0. Okay. We split this. Now we have 1,0,0,5,0. And we don't add this again. 1,0,0,5. Yeah. Let's don't add it. Split this. 1,0,0,5,0,0. We don't add it again. Now we have to add it. Plus 1,0,0,5,0,0,1. There's a 1 here. Okay. 1,0,0,5,0,0,1. But we also have to add 500. Okay. This one we added another 0, so plus 1,0,0,5,0,0,1 0. Right, and we don't add the 500. Okay. Then we don't add the 500 again, so this is just gonna add the same number but with another 0. Now we don't add the 500 and we're done. So this added a 5. So like that. Okay, so let's just add up all these numbers and see where that takes us. I got way more. That's not right. 428101984. Yeah, that's when I got way too much. Okay, I'm not gonna use this. Let's not look at the chat because the DP solution. There's definitely. Oh, but we're modding by 10 to the 9th plus 7. We're modding by 10 to the 9th plus 7. Let's see. I don't know. I don't know, actually. I don't know. This is definitely a dynamic programming question, though. Because you have multiple ways of choosing. Who's opcode? Opcode. Who's this guy? He's trying so hard to get to expert. I can feel it. He's going to get to expert one day. So you're going to get to expert. One day you're going to get to expert. Who's Rayhan? Yeah, I want to get to specialist. My goal is to get to specialist, actually. First I gotta get degree and then to specialist. I think that's my long-term goal is actually probably just specialist. I don't know. I feel like I don't have the ability to get to expert. And we'll see. But yeah, these two questions are pretty tough. It took me a while to figure it out. Maybe one day I'll get like very high. Probably when I'm an old man, maybe. I don't know. One day I will be able to solve A, B, and C. One day. Yeah, so I realized the top my rankings dropped pretty badly, but it's because of the weird time zones. Like one day it was at 5 a.m. where I live. I just stayed up and then I just couldn't solve the problem. The other day it was like at, I don't know, 3 a.m. where I lived. Whatever. Like some days it's like, I don't know how you're able to do these problems when it's a different time zone. You know what I mean? But yeah. All right, let's go back to our contest. We only have 8 minutes left. I don't know if I can figure out the DP solution. But let's see. We want the maximum closing digits. Do we want the max? We want the sum of the resulting prices after remove. So, what if at the current digit that I go through, I remove that digit? So the number is going to be 113121. 1 plus 5,101. I don't know. I'm thinking of a divide and conquer, but not actually thinking about DP. It is modulo by 10 to the 9th. Split this. Okay, if I split this, split this, split this, it's too awkward here. Remove. If I remove that, then you also have to think about what's before it. Plus the current optimal solution will get you your right solution. Duh. Plus the optimal solution. All you gotta do is add the optimal solution. That'll get you your DP. 1 plus 87. What's wrong with this? 18 plus 7. Let's go back to here. Let's try 107. Let's actually try 107. 1 plus 07. 10 plus 7. Done. 17. Is 42? This is 41. I don't know. I don't know. I don't know. I don't know. Maybe. Maybe. I don't know. Wow. Yeah, I'll always end up solving only a problem. Well then. Is it possible to get past newbie? One day. Maybe I'll put a post. Is it possible to get past newbie? Is it possible? We'll only be able to solve problem A. Not possible. Possible. Is it possible to get past? I wanted to vote. I don't know. I cannot do this. I cannot do this. I cannot do this. I don't know. You just gotta keep solving. What if you just like do a virtual contest every day? What if I do a virtual contest every day? You know? Let's just see what happens if I do that, you know? All right, guys, from now on, I'll do a virtual contest every day. All right? Daily dose of virtual contest. Maybe one day. One of the live streams, I'll be able to solve 3. One day. One day. I believe. I believe inside my heart I will. Basically, right now, I'm just wasting the time until I read the editorial because I don't know how to do C. I absolutely lost. It's not 42. Why is it not right? This is not right. I feel like one of those guys who, like, during the exam, they just don't know anything, so they just turn in the paper empty. That's what I'm doing on this problem. Like, I don't know how to do it. just submit the paper empty. Like, I don't know how to do this during any college, you know what I mean? There's some people who are like that. Like, I don't know how to do this. Too bad. Too bad, Jose. Why is this not working? What if I just submit whatever? Let's just try, okay? Let's try. 107. Okay, read and end. What we're gonna do is at the ith value, we're gonna take the I minus 1, the previous, not including it, and we're gonna add by n divided by 10. No, we need to cut the first part off, or the last part. Maybe we start at the end. Maybe we should start at the end. Don't include this. Here, we don't include the middle. How do you do that? N over 10? N over 10 to the I. What if that's the answer? You know what? Let's just try. I mean, we're at this point where, like, might as well try anything, you know what I mean? Go down to 0. Let's mod this by the what was it called? 1E7, 1E9 plus 7. Ah, crap. What if this is the answer? That'll be wild. Like, it just does this recursion doesn't even make any sense. That'll be wild. Ah, it doesn't work. Ah, crap. Well, we tried. Let's look at the tutorial. Let's count each digit as many times, including the first final sum into what place. Let's enter the length of the number n. Consider the digit ai at the place an. If some part of the number is the left of the digit is removed, then the remaining side is the remaining place, and we add the number of ways to remove the sum from the left side multiplied by the current digit. Will change, so then j plus y, then we summation from 10 to 8. Does j be used to recalculate for all values? I don't get it. Maybe I do, I don't know. Let's look at this. Ah, I knew it. Median, that worked. Hell yeah, that worked. But I don't know. Let's look at fence. Quadrilateral can be built when the max sum of the three numbers is greater than the max. To do this, you choose the max a plus b, a, b, c, or a plus b as d. I don't know. I just guessed on this. For A, I just completely guessed. I don't know. Let's look at C. Count digit, how many times will be included in the sum? What do we denote m as the length of the number n? Of the number n. Consider the ai at the digit I from the if some part of the number of the left digit is removed, then the current digit will remain in its place. We add the number of ways to remove the subsegment to the left to the answer multiplied by the current digit. Wait, what? Number of ways to remove the subsegment to the left multiplied by the current digit. Why? Why? Will change. I don't understand. I don't understand. So if we move like 107, let's start at this. Length is equal to m. M is equal to 3. Right? Consider at the ith position, 1 to m. If some of the number to the left of the digit is removed, then the current digit will remain in its place. So if this is removed, okay, let's start with 7. If 7 is removed, no, some digit on the left is removed, this 7 will remain in place. We need to add the number of ways to remove the subsegment to the left of the answer multiplied by the current digit. How many ways to the left multiplied by 7? And how do you get the number of ways to the left? I times I minus 1 over 2 times 10 to the m minus I. M minus I. Let's see, 0, 1, 2. M3 minus I is 2, so that gives us 10. So then now, number of ways to do it is I, which is the current I2, 2 times 2 minus 1 over 2, multiplied by 10. 2 times 2 minus 1 over 2. This is the number of different ways you could do it. Because it's 2 plus 1 dot down to 0, down to 1. So that's why it's I times I minus 1 over 2. That's why this works, right? Right? Then you multiply by 10. Why do you multiply by 10? That doesn't make any sense. Why do you multiply by 10 to the n minus 1? Why? Oh, because of the number of digits. That was close, sort of. No, I wasn't. I was not close at all. Okay. That number of digits, because it's 10 digits to the left. No, wait. Why do you multiply by 10? 3 minus 2 is 1. 10. Why do you multiply by 10? Oh, because we're at the 10th digit here? No, that doesn't make any sense. If the segment of the right is deleted, then the place of the digit will change. So the place of the digit become j plus 1 times 10 to the j minus I from 0 to m minus I, which equals to summation of 0 to m minus I minus 1 of j plus 1 times 10 to the j times a of I. What the heck does that even mean? J plus 1 times 10 to the j times a of I. What does that even mean? That makes no sense. I don't know. How long have I been streaming? 2 hours. I've been streaming for 2 hours. All right. Guys, I think that'll end this live stream. We solved A and B. Rate, comment, subscribe. Maybe I'll do another live stream tomorrow. I'll check you guys later.